All right, so remember, we are still in round one, and that means you're gonna get 1 point for each winner, and then we can add those up later with all of the other round ones we've been through. What you're gonna do is all these pieces of paper that you see spread out along the floor represent different types of food. And you're a little omnivore, so you're gonna try and see how many of these pieces of food you can collect. Now, this classroom, shing, magical school bus, whatever, just took us to a forest. You're no longer in a classroom, you're in a forest like a raccoon would be. And the paper bags at your desk are gonna represent your home. So take a paper bag and put it at your seat. You're just going to put it in front of you at your desk. That's right. Now, not all raccoons have the same advantage. So yes, you're all going to be trying to collect some food, but some of you have had a few accidents and might have a few difficulties. If you are at chair number 1 or person number 1 at your table, you are a male raccoon, a young male raccoon that's been looking for some territory, but unfortunately you came across a larger male raccoon before he could get away. You guys got into a little scuffle and you have a broken leg. You will be looking for food while hopping around on one leg and trying to collect some food. Raccoon number 2 at your table. Raccoon number 2 at your table, you are a female raccoon, and you got really curious. Raccoons are very curious creatures, and you were trying to investigate a porcupine. Unfortunately, you got a little too close, and you got poked in the eyeballs with the quills, so you will be looking for your food with a lovely blindfold on. Yes. Now, raccoon number 3. You are a special raccoon because you're a mama raccoon, and you just recently had 2 baby kits, and these baby kits are so small and so cute, but they have to stay at home because they're blind, and so you're going to bring back food to them. But you are going to have to try and grab just twice as much food because you have these babies to think about, so you're going to want to grab more as you can. And raccoon number 4, you've had no accidents or disabilities, so your goal is just to grab food. Now, I want you to keep in mind a couple of things. Raccoons like a variety of food, so you want to see if you can grab a bunch of different colors. And you can only hold 1 piece of food in your hand at a time. So you're going to take 1 piece of food and then put it in your bag. Go find another piece of food and then go put it in your bag. Raccoons have tiny hands. They can't carry a lot with them all at the same time because they need their other legs and stuff for moving. Yeah. You can be the blind one-legged raccoon that just reaches closely near them. All right, so let's recap. How many pieces of food can you pick up at once? 1. Are you trying to get a variety of colors? Yes. Now remember, you're going to put it all back. I'm going to set a timer for about 3 minutes so you can see how much food you can collect and what that means for your raccoon. Now, go ahead and stand up and spread out just a little bit. Don't start collecting food yet. I'll tell you when to start.
Can I go to the nurse?
Yeah. Take one back. All right. Where are my blind raccoons? All right, blind raccoons, come grab me. Do you want to be a blind raccoon? Yeah, there you go. Okay,
Richard is a blind raccoon too.
yes, Richard is a blind raccoon. Yes. Yes, there you go. Any other blind raccoons? Yes? Okay, we got blind raccoons.
Donna, take off your glasses.
All
right.
Hey, Kevin's kids. Brooklyn. Yes, but you can put it up for now.
Yes. All right, now leave your bags at your desk. You're going to leave your home at your desk. And remember, this is not a race. We're just trying to collect some food. All right. Are we ready? All right, take about 2.5 minutes. Let's see how much food we can collect. All right, go ahead and get started.
Oh, and just leave your bag at your desk.
Oh, okay.
Come on, Brooklyn, let's go. Brooklyn, you have to leave that at your desk.
Oh, good job, Alexis.
There you go.
Three, two, one. All right. Good job. Yay. Now, let's see how many of you survived. The cream-colored pieces of paper, these represent acorns, nuts, and seeds. These are 25% of your diet and worth 5 points each. Pink is strawberry, berries, things like that, 5 points each. Yellow is insects, grubs, and larvae, about 3 points each. Lizards are lizards, small rodents. The purple, those are 2 points each. Green is like leaves, grass, those are 4 points each, and blue is water. Now here's the trick. The trick is you need at least six blue pieces to survive. You have to have enough water.
I got just enough.
Just enough blue, all right. And you have to have 200 points of food in order to survive. So see if you can estimate how many points you got to see if your raccoon survived. Hey, good job.
I got 3 words. Wait, what's words?
Oh, man. Hey, you got a mind. I know. Well, we still got a bunch of food. That's awesome.
I didn't
want to
baby raccoon. You're supposed to grab even more than right.
Oh, nice. Not, ooh, 43? Yeah. I know, that's really good for not being able to see a thing. All right.
Do I add all of them?
You can add the water points into the 200. You just have to have at least 6 of them. Yeah, just one. Good job.
I got 55 points.
Oh, okay, pretty good. Not enough to survive, but we still got points. Yeah? All right, how many of you are pretty confident at this point that you did not survive? Yeah. Oh, man. Okay, and how many of you are pretty confident that you did survive at this point? All right, 1, 2, 3, 4. Okay, 4, maybe 5 survived. All right, I mean, a 4 out of...
I keep my children.
50 points per child. I'm just kidding. Yeah? Oh my gosh. All right, what were some things that made it hard to survive as a raccoon? Oh, ooh, competition. Some of the raccoons were trying to sneak food away from you. Or time limitations, time constraints. Right? What else? Yeah.
You didn't know what value the bits were.
Yeah.
I needed water.
Exactly. You didn't know you needed water. I didn't tell you which one was which. Right? What about my raccoons with, shall we say, some challenges? How did that affect your ability to get some food?
It didn't.
You're like, I got a lot of food.
I got
Didn't matter.
210.
Hey, ooh, 210. That's awesome.
Normal challenges, it was hard enough.
Some of you were like, yes, I was blind, definitely did not get as much food as I could have.
Yeah, it would have been a while.
Yeah? All right. Well, let's take a closer look at this. So what I want you to do is you are going to go to Schoology and click on the Unit 8 Raccoon Reflection.
Can we just throw these back on the floor?
Yes, you can throw them back on the floor. Yeah. And we're going to see if you can, one, learn a few things about limiting factors. sustain itself without plants and food webs they support. So we have autotrophs, which are plants that make their own food in the form of glucose. Where is their primary energy source coming from? Exactly, the sun. Then we have heterotrophs, like ourselves. They don't photosynthesize much, and so what we must find and eat sustains us and provides us energy through the forms of proteins, carbohydrates, and lipids. You've heard those terms before, right? Now, heterotrophs break down these complex carbon molecules into smaller molecules, and they use the carbon atoms to biosynthesize or to make new organic carbon compounds. All we mean by organic here is carbon-containing compounds. Now, we learned, this is a good recall. Way back with Maria's marathon, we learned what we break down these molecules into, our energy currency of the cell. Yes, ATP is our energy currency of the cell. So when we break those bonds, we release those electrons. Those electrons and their energy have to go somewhere. We put them on ATP so we can use it kind of as a transportable battery that we can use in all cells, and then we can have the energy when our cells need it. Now, let's just take a look and analyze this diagram here for a second. What process brings in carbon from the atmosphere into the food web? How do you know it's photosynthesis?
Have you learned about it?
Yes, we did learn about it.
Has the arrow pointed in, so
Yeah, it's really the only arrow pointing from the atmosphere into our food web that we're starting over here. So yes, photosynthesis is what's bringing carbon from the atmosphere into the food web. Now, different question. Which process or processes move carbon from above ground food webs into the soil? There's a squirrel there. Eventually, what's the squirrel gonna do if it eats enough? It's gonna poop, okay? And that's gonna lead to some decomposition. What else are showing arrows going from like the animals to the ground?
Death.
Yeah, death. So when those animals die, their carbon compounds have to go somewhere. So it's gonna go into the soil. So we've got pooping and death and decomposition. Two wonderful things to think about this Monday morning, right? And carbon compounds move plants to animals, or carbon compounds move from plants to animals through the process of what? Like I have carbon in these plants here. How do I get them inside the animals?
Consumption.
Ooh, consumption, like the old-fashioned disease.
No, like eating something.
Nah, there you go, like eating something. Do you guys, I think it's in like Little Women and books like that. They used to be like, if you were sick and they didn't know what it was, they would just call it consumption. Like it was just like a fancy word for cold. So if you're ever feeling really fancy in the morning, just tell your mom like, oh, I can't go to school today. I've come down with the consumption or gout. Those are the two ones. Yes, consumption or gout, two antiquated diseases. So you are no longer students in a high school biology class. You have now transformed into microscopic carbon atoms. So you're going to embody one carbon atom that's part of a molecule, and you're going to move through various carbon reservoirs in a synthesized carbon forest. It might look like your normal classroom that you're usually in, but it's no longer a classroom. It is now a forest. And I want you to remember that carbon atoms move part of the carbon compound, not as single atoms. So you are a single atom inside of a compound, but you're going to be moving around individually. So you're going to be moving between different carbon reservoirs. And what do we mean by different carbon reservoirs? Well, this is just going to be places where they're temporarily or maybe for a really long time stored and used. This could be places like the ocean. We also have animal waste, surface water, live animal consumers. You can see the little stations around the room right here. We've got surface water over here at the tall table, live plants, dead plants and animals, soil and soil organisms, decomposers and parasites, live animal consumers, what's that one? Atmosphere, animal waste, and what's the one by you, Eli?
Oh, live animal predators.
Yeah, live animal predators. Now you're going to be moving through the carbon cycle with different processes. A couple of them we've already talked about: photosynthesis, cellular respiration, decomposition, ingestion or eating, excretion. That's a fancy word for what? Poop. Combustion, meaning something is burning. Exudation, that means exhaling. Or diffusion, that's where we go from an area of high concentration to an area of low concentration. So let's write these down on page 34 so we could be familiar with some of these processes. So we'll come back to the diagram at the top, but let's write these down. In a second, you are going to be mapping on this diagram with a highlighter where you're going from station to station. So grab a highlighter. There's some in the boxes at the side of your desk, or you can use your own. That's up to you. But you're going to highlight where you go as a carbon molecule. Now, at each station, there are tickets. And these students will travel to different stations, and as they travel to a station, what they'll do when they get there is they'll pick up a ticket, and the ticket will say something like, "You are part of a woody tissue of the lodgepole pine tree where you are stored for 80 years before the tree dies. Death. Count to 80. Go to dead plants and animals." So then they would highlight here where they would go, like here they would go into the soil, death and decomposition, so they would highlight that. And then it says go to dead plants and animals. So I keep the ticket there, and then I travel over to dead plants and animals. And here I would pick up another ticket, and that ticket would tell me where to go next. So by the time they're done, they will have highlighted all over this map where they've been, and then we can analyze what's going on with the carbon cycle. Like, why are things rotating? Why does carbon move at all? Why do some areas have more carbon than others? Stay at their stations, but you move between the stations. And then you're just going to keep traveling until time is up and see how many different places you move to as a carbon molecule. Might you visit the same place more than once? That sounded like a weird sentence, but I'm glad you knew what I meant. Yes, you might visit the same place more than once, and that's okay. So you might have multiple arrows going between the same places. All right. Now, before we get started, make sure you're on the carbon cycle one with the forest. We're going to do the water cycle one later. So you want the one with the fox, the wolf, the squirrel, all that stuff. All right, go find one of these stations, any station around the room. They're kind of in a U shape back there. It does not matter which one. Ooh, so with burial and sedimentation, these two were once living things. But when they start decomposing, where is it gonna go?
In the ground.
In the ground, right? So that would go from the biosphere to the geosphere. There you go. Yes. But why are they bigger?
Yeah, I like this. Wait, it's gonna be like a weird angle.
I'm out of stupid answers, and I'm not smart enough to come up with a smart one.
Well, which one is probably moving more carbon?
Oh, I didn't even look
The
at
pink one.
The pink one. And who causes the pink carbon arrows to move?
the humans.
The humans. So are humans moving more carbon than nature?
Yeah.
As I said, Genghis
Yes.
Khan had the right idea.
Yes. Yes, we are.
Read about it wrong.
What can I say? All right. So burial and sedimentation. How is that moving things? That would move it to the hydrosphere, right? Because it's going from like the land to the ocean.
Yeah.
Yeah, there you go.
Hey, Nick,